and thank you very much. So today I'll be talking about the rocket women of ISRO. Since we were talking about women and women in science, I would focus closer to my area, and that's it. So first of all, I would like to show you something which probably you all have seen, but it's a very beautiful ad which is there on TV, and it captures some important points which I'd like to talk about. So I'll first show this to you. This is little Santo, a little girl who I will mute it. So this is a little Santo who is very fascinated by Mars, and she wants to become an astronaut. So you see in this video, in this ad, while she tells her friends, parents' friends, that she wants to become an astronaut, most of them think of it as a very unachievable dream. And the girl, like you can see, is not too happy, but she's very enthusiastic about space and about research. So you see that here she has her father's helmet. Santo has a father's helmet which she colors, and she's still very fixated to the idea of actually going to Mars, while her parents actually think that she needs to focus on her exams, on her on her studies, because that's what she should focus on. But you can see that the father over here understands that this is Santo's dream. She is interested in this, and therefore you see that when Santo goes to school, everywhere where she goes, she keeps thinking about things about exploring Mars and various things, and she tries to do various projects at home where she makes a study of Mars. She's studying magnetism. This is a levitation toy she has made by studying magnetism. And you can see that this child is totally obsessed with this fascination of going to Mars. So when her mother comes to her room in the night, you can see she has the solar system model. She puts up the lights, and there are stars which come shining up in her room, in Santo's room. And that's when the parents realize that this girl, this little girl, really is very interested in pursuing her dream of actually becoming an astronaut and going to Mars. And you see that as this thing progresses, the parents begin to understand that Santo, the little girl Santo, is truly interested in this exploration, and that's when they gift her the yoga laptop. So the ad is basically for a laptop, but it conveys very important questions that come to our mind. For example, the very question about can women do science, and how strongly society in principle even opposes women who want to do science, because they often think that that's not what they should be doing or what they are capable of. And so we come to the important question that can women actually do science, right? And if you actually see in India itself, our history, Anandibai Joshi, she was the first female doctor of Western medicine. And you see that she actually did her degree in the United States, and this was in 1886, a very long time back. But then in 1933, you see, as recently, this is not even 100 years ago, you see Dr. Kamla Soni, who was actually denied admission in the Institutes of Science by none other than our Nobel laureate C.V. Raman. C.V. Raman himself was very convinced that women cannot be doing sciences, and therefore you see that it's inherent in India and in our institutes, where people do believe that women are not born scientists. So if you actually see IISc, which is the Indian Institute of Science, which is a premier institute for scientific research in India, you see that in the 1960s only 2% of you had students were female, and now after so many years of independence, after 75 years of independence, the number has risen to 19%, which is still not yet very good, because in principle you should have a good 50-50% divide between the male and female students, which shows you that this is still a problem which has to be very seriously handled. If you look at the global statistics, then women make up only 28.8% of those employed in scientific research, and they are less likely to enter into careers in STEM, and they are poorly represented in science academies. Only 12% of female members are present in the 69 science academies worldwide. Similarly, only 19 women have been awarded Nobel Prizes in sciences since 1901, and in the 3 science categories. And if you see in 2018, the joint winner of the Nobel Prize was Donna Strickland. She was the first female laureate after a big gap of 55 years to actually get a Nobel in physics. And in 2020, Andrea Ghez shared the Nobel Prize in Physics for her work on the stars close to the center of the galaxy. If you look at the Indian picture itself, one of the most prestigious scientific prizes which is given by the Indian government is called the Shanti Sarup Bhattagar Award, and it has been given only to 16 women out of a total of 500 since its inception in 1958. Similarly, women also receive less than 5% fellowships awarded by the three major science academies. They are quoted less often, and only one out of the Indian National Science Academy's 41 office bearers was a woman, and just 14 one of INSA's 501 awardees was women. So you can clearly see that there's a clear dearth of women in STEM in India, as well as in leadership positions in STEM. Now today I'm going to focus upon the rocket women, as I've called them, the women of ISRO, and we're going to focus on their achievements to actually see how, though in ISRO only 20% of their workforce is made up of women, but women have very strongly contributed to the programs of ISRO. But however, no woman has reached the top rank in ISRO since its inception in 1969. So that is something which we look forward to in the future, where women would actually spearhead ISRO. So what I'm basically going to focus about today is about role models, because I think that's very important for our young female students, for them to actually see role models who've actually been achieving things in fields in STEM, because they could be an inspiration to our young girls, and they could also be a source of inspiration. So, but the story I'm going to tell you today is very closely linked to our space program, and therefore I'm going to start off with the inception of our space program, which was in 1969 on 15th August when ISRO was founded, and the father of ISRO was Vikram Sarabhai, and this is just a short while after the independence. So obviously the biggest question was, why does India need to be part of the space age, right? Because space is a very expensive kind of research that has to be done, and India at that time had just got its independence, and there was obviously a lack of funds, lack of potential, and therefore the big question when Vikram Sarabhai proposed the space program was, why do we actually need to have it? And that's when Vikram Sarabhai said that we are not doing our space program to actually compete with economically advanced nations, but we are convinced that if we have a space program of our own, then we can actually use it to actually develop our country, and we'll actually see how in this case, where the space program has actually helped in the development of the country, and actually in the of many disasters which could have actually hit the country, and therefore the whole space program in India was actually done for the development of the nation. It was basically to solve problems of man and society. We were not trying to fight in the space age, but we wanted to basically use it for the betterment of man and society. So let's start with the humble beginnings of ISRO, the 1961. These are very iconic pictures where you see that you have sounding rockets and various apparatus which was being used by ISRO, which was literally taken on cycles and bullock carts. And this basically shows that ISRO, as it was earlier also and even now, it basically worked on a very tight budget. They always had to work on a very tight budget, and that's when they actually, they worked on this tight budget to actually build up their things. So like I said, what were the basic ISRO objectives? You had of the development of man and society. So India actually, a short while after independence, you have 1969 independence, and a short while after that, in 1975, we actually launched the first satellite with the help of the Soviet Union, which was called Aryabhatta. And 5 years after that, India itself launched its own satellite called Rohini by the Indian-made launch vehicle, which was called the SLV, which was the Indian-made launch vehicle. And then we developed various more powerful launch vehicles so that you could continue with the space program with independence from any foreign service. And that's when they developed the Polar Satellite Launch Vehicle, the PSLV. And then we had the GSLV, which is the Geosynchronous Satellite Launch Vehicle, which was basically meant for placing satellites in geostationary orbits. Now, satellites are placed at different orbits in different heights depending upon the purpose of the satellite. For example, a surveying kind of satellite needs to be at a height of not more than 200 kilometers if you want to survey the land. But for example, if you want to actually have a satellite which is always overhead a certain place, which is called a geosynchronous satellite, it's always on top of the sky in a particular place, then you have to put it at a certain height, about 36,000 kilometers, so that it rotates with the same velocity as the Earth. It will always be for that. And that's what's used for geostationary satellites, which is catering to a particular region. Polar satellites actually loop around the Earth so that they can actually scan the Earth in an effective manner. And depending upon that, you need to have accordingly the launch vehicles, depending on the kind of satellite and the purpose of the satellite. So let's start off with, we won't talk more about satellites in the sense of the other kinds, but we are going to go to the ones which are related to astronomy. So first of all, let's go to the moon. Now in 1969, the Americans already landed on the moon. You had Neil Armstrong on the moon. But in spite of that, the moon is still a very interesting object to explore. The moon is the closest cosmic body on which you can actually, which is the closest one to land on. And it's a promising test bed, and therefore Chandrayaan, you had so Chandrayaan 2, we had Chandrayaan 1 and Chandrayaan 2. These were two missions sent to moon. And these are basically not only to stimulate the advancement of technology, but also there are many propositions of things that can be done from the moon, which is of interest to the Indian government too. So we'll start off with the first mission, which was Chandrayaan 1, where India was only the 4th country to go to the moon. And this was actually launched in 2008 by the PSLV launch vehicle, the Portal Satellite 1. And it actually carried 5 ISRO payloads. And but unfortunately in 2009, within a year's time, rather less than a year's time, there were certain technical issues with the mission, and therefore the mission was closed in this thing. But in spite of that, in the short period that Chandrayaan 1 worked, it actually found a very important finding using what is called its mineralogy mapper, which is called M3, and they actually discovered water on the moon. So the first thing of water on the moon, it was claimed by the Apollo astronauts 40 years ago, but Chandrayaan 1 actually got definite evidence of the presence of water on the moon in that short period in which it's operated. After that, we had another mission which was called Chandrayaan 2, which was the follow-up mission to Chandrayaan 1, which was in 2019, 10 years after Chandrayaan 1, which actually included a lunar orbiter, lander, as well as a rover, which you can see over here. And if you see Chandrayaan 2, let's come on to the women now. You can see that the project director of the mission Chandrayaan 2 was Muttaya Vanita, whom you can see over here on the left. And she was responsible for this whole project from the start to the finish. The project was almost 1,000 crores. It costed 1,000 crores. She specializes in digital signal processing, has written various books on satellite communications. So she was the project director, and the mission director was Ritu Karidhar, and she was the mission director for Chandrayaan 2. So you can see, and she was also for the Mars mission, which we'll come to in a short while. And so both these women were spearheading the Chandrayaan 2 project. So Ritu Karidhar, whom I just spoke about, she worked for Chandrayaan 2 as well as the Mars mission. She was the mission director for this. Ritu studied in the University of Lucknow, did her bachelor's over there, did her master's over there too, and enrolled in a doctorate program at Lucknow University. But then she also got an admission in ISC Bangalore, where she got a master's in aerospace engineering, and later on she was also conferred an honorary DSc by Lucknow University. So these are the people who were there in Chandrayaan 1 and Chandrayaan 2. So you can see that there was a big step up in the mission of Chandrayaan 1 and Chandrayaan 2 in the kind of science that was achieved by Chandrayaan 2. And one of the most important things about Chandrayaan 2, this was launched by the GSLV Mark II launch vehicle, and you had it launching, and you actually had a moon lander which was called Vikram in memory of Vikram Sarabhai. But unfortunately for Chandrayaan 2, Vikram, the launcher, actually failed. Some of you all may have seen it, that in the last 2 kilometers while the lander was landing on, it was supposed to do what is called a soft landing on the surface, but in the last 2 kilometers there was a malfunction in the final moments, and the lander actually crash landed. It did not have a soft landing as planned, and that was a failure. But the orbiter, which is there of Chandrayaan 2, is still functioning and still sending a lot of information about the moon onto the Earth. So in a way, it's still a successful mission. So like I said, that water was actually found by Chandrayaan 1 as well as explored by Chandrayaan 2 also. It also looked for various minor elements, and it actually has mapped nearly 95% of the total lunar surface in X-rays for the first time. It actually detected various materials on it and studied, and is still studying the moon in very big details. Now, Chandrayaan 2 was special for a simple reason. The first thing is that it was the first space mission which actually went to the southern polar region, and it actually had all the Indian technology which was used in the launch. Now, after Chandrayaan 2, the next big mission that ISRO took up was called Mangalyaan. And the thing with Mangalyaan is that if you look over here down, this is the orbit of the Earth. You know, the orbit of Mars is outside the orbit of the Earth. The Earth's orbit is about 365 days, Mars' orbit is about 387 days. And what you can see is that the close encounter of Earth with Mars happens every 26 months. And therefore, when Mangalyaan was planned, there was only 18 months for this close encounter. So that was the tight deadline that people had to actually make it for the Mangalyaan mission. Now, the Mangalyaan mission was launched in 2013 with the PSLV launch vehicle. And the PSLV launch vehicle, if you can see, I'll show you over here. Here you know the order of the planets. There's Mercury, Venus, Earth, Mars. So that's the kind of distance which we needed to go to. And Mars has always been interesting for everyone, not only with science fiction, but even for hardcore scientists. And what you can see is that the race to Mars, going to Mars was not an easy job at all. So if you can actually see over here, USSR, or former Soviet Union, actually had 10 failures before they finally had a successful landing on Mars. The Americans actually had 5 failures before they landed on Mars, and therefore India in principle was the first country to land on Mars in their first attempt. Okay, otherwise all other countries always had it more than 1 failures. Like you see, the Russians with 10, the Americans with 5 failures, Japan tried it, had a failure, and there were various, there's a Chinese one which was Grunt, which actually failed at the launch itself. So you see that it was a very difficult job to be actually doing it. And when the Mars mission, or Mangalyaan, it was also called the MOM, which is the Mars Orbiter mission, it actually was launched together with another mission by the Americans, which was called the MAVEN mission, which was again to Mars. Again with the same deadline of reaching Mars in September 2014, because that's when it had its close passage. So Mangalyaan mission, or the MOM mission, you can see it's a very small satellite, about the size of a small car, a Tata Nano kind of a thing, about 1,300 kilograms, and that's the satellite. And here, let's come to the women behind Mangalyaan. So if you see Nandini Harinath, she was actually the project manager, the mission designer, and the deputy operations director on the Mars Orbiter mission. And therefore, she, you can see in the picture itself, this is a very young engineer who actually had to take up this job, which was a very daunting task for her, a very difficult one. But she did it in a very good way, and it was a very successful mission. It's there on our 2,000 rupee coin. If you road note, if you see, there's the MOM mission, the picture of it. And then you also see Meenal Rohit. Meenal Rohit was is a BTech in computer electronics and communications from Ahmedabad, and she then joined ISRO, and she was part of the MOM mission. And you can see that she had to actually work in a windowless room, often for 18 hours a day, to prepare for the mission. She was also the designer of a couple of instruments even on Chandrayaan 2. That's Meenal Rohit. Momita Datta is also one of ISRO scientists who was part of the MOM mission. And one of the important things of the MOM mission was actually to look for methane on Mars, because methane is an indicator of life on a planet. And there were various detectors on other missions too, but the one on MOM is also a very important one, which can very well trace methane on Mars, and that's what it did. The other very important, this is the MOM mission, which you can see over here. Another very important part about the MOM mission is that the launch vehicle we have in India is not very, it cannot directly shoot to Mars. So we'll actually come out to a very unique technique which was used by ISRO to launch to Mars. But before that, we can have a look at MOM, like I told you, about 1.3 tons. And it had it had 5 instruments on board, which were basically to study Mars in more detail. We don't have the time to go into each of these, but you can find details of this probably on the net, and you can actually check on these things. Now, the important part about the MOM mission is you can see that when the MOM mission was, the launch vehicle which ISRO has does not have the capability to go directly to Mars. And therefore, what we actually did was something was called a slingshot kind of a thing. In the sense, you have the satellite being launched on a first orbit over here, and then you have thrusters or boosters on the satellite with which you increase the radius of the orbit in the second orbit, and the third orbit, in the fourth orbit, in the fifth orbit, and finally in the sixth orbit. That's when the satellite managed to escape the gravitational force of the Earth and aim directly to Mars, which you can see over here. But this is a very carefully calculated orbit. You actually need to know very well how to fix these thrusters so that finally you go there. And then when you come to this point, this is the most important point, which is the Mars insertion. At this point, you actually have to slow down the satellite so that the satellite gets captured by Mars. And that's the Mars insertion orbit. In case you have a larger velocity, the satellite will fly by. If you have a smaller one, then Mars will just gobble it up and it will fall onto the surface of Mars. And therefore, you can see that in this mission, which is also called the mother of slingshots, you actually have these various slingshots, 1, 2, 3, 4, 5, and then in the sixth one, you actually land up over there. But that's the only way it could be done with our PSLV launch vehicle, because PSLV launch vehicle cannot send such a large satellite directly to Mars. It does not have that kind of capacity. So once it's shed off, which is within the first 1 month, then it took about 299 days for it to reach to Mars. And then the important point is that after 200 days, after 300 days, when it reaches Mars and gets inserted onto the orbit, then the satellite has to wake up, right? It has to start off again. It has to wake up from its long hibernation and come out into operation. And therefore, that was a very crucial thing. One was the crucial part of actually calculating these orbits so that it reaches Mars. The other thing is, how do you actually do the MOM insertion? And when it was inserted in Mars orbit, initially it was behind Mars, so we could not get any signals from it. But once it came in the front, that's when they actually got signals from the satellite. And this is a very important moment when the satellite actually came from front of Mars, and that's when the signal was detected from the mission. And you can see this picture is a very iconic picture of women in saris and brightly colored saris, actually looking really jubilant about the mission. And that was the success of the Mangalyaan mission, which was something very important and something to be very proud of. Now, if you actually look at the economics, I wanted to speak about this a little bit. Again, the same question which often people ask about is the cost of the space mission. How much does it cost us? So if you actually see, the distance to Mars is about 400 million kilometers. It costed us about 450 crore rupees to do the Mangalyaan mission. And if you actually see, it's really very funny. If you actually see, divide this by this, you will see it has barely costed India 11.25 rupees per kilometer, which is actually the cost. Instead, I think auto rickshaws now already cost more than that, and this Mangalyaan mission actually costed less than that. The American mission, which was also launched, called Maven, it actually costed 10 times that amount of money, and basically because their launch vehicle is much more powerful and it was done in a different technique. While the Indian one, with a smaller launch vehicle, we had to use some specialized techniques. And just to compare the budget which India is using on its space program, you can see that the military budget is about 2.2 lakh crores, which is the annual budget, while you can see that the budget for Mangalyaan was just around 450 crore rupees. The firecracker market in India costs about 5,000 crore rupees. The movie Gravity actually costed more than the Mangalyaan mission itself. Similarly, a movie you all could be familiar with called Robot, which was a Bollywood movie, it actually cost comparable. Mangalyaan was about 3 times the cost of that. Bullet trains will cost much more, as well as the money spent in higher education is also, this is just a fraction of that amount of money. Now, the Americans used the Saturn V5 rocket to actually launch Maven, and you can see that basically the difference in cost. I would also give justification of why does the Maven mission cost much more. That's basically because the Saturn V rocket is a much more powerful rocket than our rocket, which is the GSLV Mark III. So you can see GSLV has a barely this thing of only about 8 tons, while Saturn V is 140 tons, right? So even the reason why the Americans had to spend so much more on their mission is basically because their launch vehicle itself is much more powerful. They did use much more fuel to do that. So that justifies why they spend so much. But India, since we have a very frugal budget for our space program, we can actually compare our space program. You can see this over here, which has costed the Mangalyaan mission, which has costed obviously much lesser than the amount spent by the Americans on the Maven mission, or this is the Europeans. The Europeans actually sent a mission called the Mars Express Orbiter, which you can see is also a lot more expensive than the Mangalyaan mission. And here there's a comparison with the Japanese mission as well as the Russian mission. So you can see that the Mangalyaan mission has been of the lowest cost. It has been on a very controlled, tight shoestring budget. The other important thing that ISRO has done has been in AstroSAT. Yeah. It says like, hello, can you hear me? Can you hear me? Yeah.
Yes, madam, we can hear you.
Okay. So you can see, I need to mention this also, that India has a satellite which has been specially launched only for astronomy. So you can see that this is a satellite called AstroSAT, which basically has 3 X-ray telescopes, SXT, LAX-PC and CZT. This is an ultraviolet telescope called the UVIT, and there's an optical one which is called the Scanning Sky Monitor. And this is the AstroSAT, and you can see that the person behind AstroSAT is Dr. Sita Somasundaram. She did her BSc from Delhi University, Masters from IIT Madras, and after that she did her PhD in physics from the IISc Bangalore. Now Sita has been the space mission, she led the Chandrayaan 2 mission, as well as she is the program director for the space science program and the principal investigator of AstroSAT. So that's Sita. And so you see the AstroSAT has made major contributions on astronomy in India, and you can see that, like I said, you have an optical telescope, you have ultraviolet and you have X-ray bands with which very important discoveries have been made. I don't have the time to go into the details of that, but you can find it on AstroSAT achievements. So this is a description of the instruments which are there on AstroSAT. These are the 3 X-ray telescopes. This is Scanning Sky Monitor and this is the ultraviolet telescope. So launch of AstroSAT took place in 2015, and this was launched, this was the C30, the 30th launch of the PSLV, and it has an orbit of about 650 kilometers. It's above this thing with a slight inclination of 6 degrees. So here you have a further description of AstroSAT and its telescopes, the instruments which are there on board. Like I said, I won't have time to go into the details, but these are the approximate instruments. Again, if you compare, you can actually make a comparison of the cost of, this is Chandrayaan with other important things, right? Yeah. Now, often you must have seen in the pictures that these satellites seem to be covered with gold foil. Now, it's not gold which is actually there on satellites. This is a multi-layer installation, or it's called the MLI. And basically these are a single layer of aluminized polymidine with a silver aluminum side facing it. And the yellowish gold color of the polymidine on the outside actually gives the satellite the appearance of being wrapped in gold. But this is obviously not in gold. You can see this material over here in more detail. This is the same thing. You can see that there are layers in this, right? These are layers which actually provide insulation, because you see one of the biggest problems for satellites is the exposure to radiation, which the satellites have when they are out in space. Right? So what are the future plans of ISRO? So ISRO, after Chandrayaan 1 and 2, obviously like I mentioned, Chandrayaan 2 had a failure with the lander, which was called Vikram, and therefore there's a new project called Chandrayaan 2, which is again planning a lander, which would be a successor to the Vikram lander, which failed, but which should hopefully work out. So Chandrayaan 2 will have a lander, a rover, and a propulsion module. The other important mission which you all must have heard about for ISRO is called Mangalyaan. Mangalyaan is the Indian mission of actually sending man to space, and it was expected in 2022, but the latest dates say that it's getting pushed by at least 2 years, 1 or 2 years. But this would be the first Indian human spaceflight program. If you remember Rakesh Sharma was the first Indian out in space, but that was on the Soyuz, which was done basically with Indo-Soviet collaboration. Mangalyaan is being planned to be totally through ISRO. So ISRO will launch as well as do the things. But ISRO is obviously collaborating with various countries, which include Russia, France, Canada, etc., which are actually involved in the Mangalyaan mission. There's another mission which is being planned on lunar polar exploration, on studying the poles of the moon, because we know that the poles of the moon, there is ice on the moon, on the poles, and that's what we'd like to study. A very soon upcoming mission, Aditya L1. This is a mission which will just study the sun. Okay, and this was originally planned for 2022. It should go off maybe in the end of this year or the beginning of next year. This is to study the sun. And then there are a whole bunch of other ones. You have Mangalyaan 2, which is also being planned, and there is Chandrayaan, which is to Venus. That is also another mission which is being planned by ISRO to study the atmosphere of Venus. So here I have a little bit on Aditya L1. So you can see Aditya L1 is made to study the sun, and it has a weight of about 400 kilograms. It will sit at a point which is called the Lagrangian point, which is where the gravitational forces of the earth and the sun get balanced, and it will just study the sun. Mangalyaan 2, which I mentioned. So Mangalyaan 2 will be used, which will have a lander, and it will be launched by the GSLV Mark III, and like it's also with collaboration with France, and that's the thing. Mangalyaan I mentioned to you, to send 3 persons in space, of which one is being planned to be a woman. So hopefully one of them will be a woman. So at present ISRO is basically working on this part of the experiment. Launching the rocket is not a difficult job. The more difficult job is getting the astronauts back. So here you can see in this picture, these are the experiments which now ISRO is dealing with, is of when this thing comes back into the Earth's atmosphere. These are parachutes. It basically will fall into the Indian Ocean, and then it has to be retrieved. And from this you'll actually get your astronauts who are sitting inside this thing. So that is what ISRO is basically focusing on, is on these, how do they get back the astronauts from this. So 2022 and 2022-3, they'll be doing experiments on retrieval of this, of the vehicle, before they actually try out doing sending humans in space. So what I was trying to talk to you about in this talk was about some of the rocket women. We can call them the rocket women because they are the ones who are actually behind the space program in ISRO. Obviously there are men there too, but there is a decent, appreciable amount of women contribution in our space program. And if you actually read many of the women who actually work in ISRO, they have been very appreciative of the way in which ISRO handles their women employees. They actually say that they are treated on par with men, and that's how they are often even made in charge of various missions, which they are very proud of the success they have actually achieved in these missions. And there are some more which I should mention. There's Anuradha TK. She's ISRO's senior most woman officer. She actually joined ISRO in 1982 when there were just a handful of women engineers. She's been the project director of the GSAT-12 mission, as well as she's worked for ISRO for the past 34 years, and she works basically the key area of what are called geosynchronous satellites, okay, which are basically geosynchronous, that they lie above a certain location on the Earth. There's Valarmathi, who is the project director of RISAT-1, which is RISAT-1 is the radar imaging satellite, okay, which is RISAT, and she is the first person to actually achieve to receive the Abdul Kalam Award instituted by the government of Tamil Nadu in honor of the former President Abdul Kalam. Tessie Thomas is actually called the Missile Woman of India because she was the Director General of Aeronautical Systems and the former project director of Agni 4 missile. So Tessie Thomas did not work in ISRO. She worked in the DRDO, the Defense Research and Development Organization. But because it's missiles in space, that's why I included her in this talk. But she's the first ever woman scientist to head a missile project in India. There is B. Koda Nagoy, who is actually the group head of the Satish Dhawan Space Center at Sriharikota. She's a graduate in engineering, and she basically worked on the augmented satellite launch vehicle as well as the reusable launch vehicle. Lata Ambika is the deputy director of the Vikram Sarabhai Space Center at Trivandrum. She has a master's degree in control engineering. She joined VSSE, the Vikram Sarabhai Space Center, in 1988, and she heads the control, guidance and simulation entity at the institution, okay, at Trivandrum. And here we have a younger part of the team, Kriti Faujdar. Kriti Faujdar is part of the team that actually monitors satellites and several other missions continuously. So the satellites that are launched by ISRO have to be continuously monitored, because you can see that while they are out in space, there are various gravitational forces because everything moves in space. The Earth, the Sun, the planets, all other objects move, and therefore satellites also, they often change their trajectories because of the influence of other objects, and therefore they have to be constantly monitored. You have to monitor the satellite. The satellite has thrusters, and the thrusters are little engines with which you can kind of guide a satellite to move in a certain direction or adjust its orbit depending on what's required. So this is something which has to be done 24/7 all day for all satellites, where you actually monitor how are they moving and what are they exactly do. And that's exactly the kind of work that Kriti Faujdar does on monitoring satellites and several missions. So these are a few of the names, and there are many, definitely many more unknown names whom I'm not talking about today. Number one, because of want of time, and number two, because some of them are unknown names we do not know. But there are still definitely many, many more women in ISRO who are actually contributing. And therefore, I would like to conclude with one last wish, that I would say that for women in STEM or in sciences, it's basically a question of a wish. For example, a freedom of choice. I do not say that all women need to be doing science or doing STEM, but women should also have a freedom of choice in the sense, if they do want to do STEM, they should be able to do it. They needn't be forced to do it, but they can do it if they'd like to do it. And there should obviously be equal opportunities for men and women to actually do it. I would say that as a woman, I would say we do not require any reservation. You do not need to have reserved seats for women. Women can definitely compete with men for positions, and they can definitely win in the competition and actually get those positions which they would like to have. I would say that we do not need any kind of reservation. Let it be where the individual is non-gendered. You look at a gender, at an individual without the gender, because after all, other than reproductive organs and hormones, in principle, men and women are all equal. So I would like to conclude with this positive statement by Carl Sagan on why space exploration is so interesting and so important for all of us, because exploration is in our nature. We began as wanderers and we are wanderers still. We have lingered long enough on the shores of our cosmic ocean. We are ready at last to set sail for stars. And it would be best if, when we set sail for stars, women and men, both of them, get an equal opportunity to be part of this exploration and enjoy this journey of actually exploring space. So I would like to conclude with that, and thank you very much.
Thank you, madam,
Yes.
for readily accepting our invitation in spite of your busy schedule. And you have shared a lot of information, and we have gained a lot of information about this ISRO, the space, Chandrayaan, everything. And now I call upon Lakshmi Prasanna for formal vote of thanks.
Thank you, madam. Thank you for giving me this opportunity. Thank you, madam. On behalf of the Mathematics and Statistics Department, it's my privilege to propose vote of thanks for this today's International E-Symposium on Mathematics. First of all, I thank today's resource person, Priya Hasan, madam. Madam explained about Chandrayaan and Vikram Sarabhai space, explained about all these things, madam. So how to calculate the orbits using mathematics and economics missions and compared to 10 times of the American. So in new Chandrayaan also, so what are the studies there in Aditya, Mangalyaan, Sukragraha? So these are all you explained elaborately, madam. Thank you. Thank you for accepting our invitation, madam. My sincere thanks to Professor K. Mucham Reddy, sir, Secretary, Hyderabad Mahila Vidya Sangam. I thank Professor G. Sudarshan Reddy, sir, Secretary cum Correspondent. I thank our Principal, Dr. J. Achyuta Devi, ma'am. And I thank our Head, Department of Maths and Stats, Shweta, madam, for organizing the extension lecture. I thank my dear colleagues and students for attending today's session. Thank you for giving me this opportunity. Thank you, one and all.
Principal madam as well as the branch people, sir. Okay. But afterward, this changed.
This is my duty.
Thank you, madam. Thank you for your quiet acceptance, madam.
Yeah, my
We
pleasure.
are very grateful to you, madam. Participants, if you have any questions, so that madam will be, feel free to ask the questions so that madam will be glad to explain you the doubts, what you have. Anyone? I think they are quite clear, madam, about what you have said.
Yeah, okay. Let's hope.
Okay, madam. Thank you, madam. Once again,
Yes.
thank you, madam, from the
Yes.
bottom of my heart.
Yeah, thank you. I can exit, right?
Okay, madam.
Yeah, okay. Thank you.
Thank you.